first open up Maple, you'll see the Start page. This page points to a variety of resources for both new and returning users. It can be turned off from showing up at launch by selecting the Do Not Show This Page field right here. You'll notice there's two buttons up here in the top left, one saying New Document and one saying New Worksheet. This guide will be completed in document mode, so I'll select New Document. We can begin by typing in some math. We'll start with something simple, like 1 plus 2. Then you could hit Enter and see the evaluation on the following line. Same line evaluation is also available in Maple. To do this, type in your expression, something like x plus 5 minus 2, and then hit Alt-Enter, and you'll see the evaluation now pop up on the same line. Looking over to the right, we can see the context panel. It can be used to perform a wide variety of operations, and the options change depending on what expression or object your cursor is on. For example, we can select the most recent result, head over to the context panel, and choose something like Integrate, and then select the field X. It's also possible to generate plots from the context menu. To do this, again, I'll select our most recent result, head over to the context panel, choose Plots, and then 2D Plot. An important thing to note is that math in a Maple document is live. You can go back, make changes, and re-execute the problem to obtain a new result. For example, I can go back to our very first calculation, change this 1 to a 2, and you'll notice it doesn't change immediately, but as soon as I hit Enter, the result will update. We can also see this down here. If I add a coefficient of 10 to x, and then select the entire line, and choose the Execute Selection button up in the ribbon with a single exclamation mark, it will re-execute my selection. As an additional tip, you can use the Execute Worksheet button to execute the entire worksheet at once. It can be found here in the ribbon or up here at the very top. For example, maybe I make a change here, and I also make a change down here on this line, and instead of selecting everything, I can just choose the Execute Worksheet button, and it will change all the calculations accordingly. Another interesting feature in Maple are smart pop-ups. I can type in an expression here, such as sine of 2x, look over to the context panel, and you'll see these smart pop-ups up here. They'll show you the result or a preview of the result before you apply it. So I can look at trig identities and view a list of equivalent forms that I can use. To enter in fractions, we can use the / key. For example, I can write a/b and create the fraction a over b. An important thing to note is that Maple calculates exact answers. So this means fractions will remain as fractions, and symbols like pi will remain as themselves. For example, we can write something like pi. To do so, go to the palettes, common symbols, and select pi, and then write something like +1/2 + 1/3. Hit Enter, and we see that Maple gives the result in exact form. Although, we can obtain an approximation of this by selecting it, going to the context panel, and choosing Approximate. An important thing to note is that if you have a numeric approximation at any point in your expression, Maple will give the result in a numeric approximation form. For example, I can write 0.33x + 1/3x, and since I have a numeric approximation as the coefficient on the first x, when I hit Enter, it gives the final answer as a numeric approximation. Although, we can change the format of this by selecting it and changing the field of number format in the context panel. Speaking of palettes, Maple has over 1,000 expressions and symbols within its collection of palettes, found on the left here. Some of them insert fill-in-the-blank templates that are very useful for problem entry, one of which is the definite integral template. We can use Tab to work our way through the different fields inside the template and enter in whatever problem we'd like. Then, we can hit Enter and see the result of the definite integral. An important thing to note is that you can put frequently used palette entries on the favorites palette. To do so, right-click on the desired expression in the palette, and then click Add to Favorites palette. We can also use symbol completion to enter in different symbols. To do this, type the first few characters of the symbol name and then press escape and choose the desired symbol from the list. For example, we can type something like SQRT, hit escape. Then we can use the up and down arrows to sort through the different fields and click tab on the one we wish to enter. We can do this again by typing E, again escape, and then clicking tab on exponential E. I can then make this the exponential function by typing the up arrow and then X, using right to get out of the square root, and then write something like pi, again clicking escape, and using the up and down arrows and tab to select the entry which we'd like, or we can just use our cursor to select it if we wish. Then, clicking enter, we see that it will give it in the form like this, in exact form. Another thing we can do is we can actually use the same mechanism to enter in different templates such as integrals. We can do this by typing int, and then same thing, escape, and then sorting through the fields and selecting tab on whichever we wish to use. Another important thing to note is that Maple is case sensitive. For example, if we type x plus x and hit enter, we get 2x as we'd expect. Although, if we write something like x plus capital X, we can see that these two are being treated as separate variables. Another thing to note is how to use multiplication in Maple. You can do this in the normal way you'd expect by writing something like 3x plus 4x, and it will give the result of 7x. If you look close enough, you'll see that Maple has entered in a space here to show the implicit multiplication. Whenever you enter in multiplication, you can do this as well, or you can use the asterisk notation for multiplication. So I can write 3 space x plus 5 shift 8 for the multiplication dot x, and it will give 8x as expected. Implicit multiplication offers convenience and additional typesetting options, but if you use spaces for multiplication, then you have to be careful, because if I write something like x space y plus xy with no space and hit enter, these two will be treated as separate variables. Since this is reading this, or it's reading the first one as x times y, and the second one as the variable xy. A cool thing about Maple is that it understands familiar mathematical notation. For example, if I type in y prime prime plus y prime plus y equals 0, it will recognize that this is a differential equation in y. So I can go over to the context panel, select solve DE, and then choose the field y of x to obtain a solution to this differential equation. You may have noticed, as I've been working through, that there are label references at each evaluation. This happens whenever you use enter to get a response. To refer to a previous result in a computation, you can use Control and L to enter in the label reference number. For example, we can use this from earlier in a computation. So it has label reference number 6, so I can click Control plus L, enter in the identifier 6, and then write something like shift 8 for multiplication times x, and we can see that it'll use that entry from before. Something you may want to do often is assign variables. To do this, you have to use the assignment statement notation, which is denoted by colon followed by an equal sign. So we can enter in something like cost colon equals 10 to define a variable called cost and give it the value of 10. We can now use this variable in calculations. So if I want to compute 2 times cost, it will give 20 as you'd expect. An important thing to note is that Maple performs calculations only when you ask it to. If we change the value of our variable, we need to re-execute the statements that depend on that value to get the updated results. For example, if I change the value of cost to 20 and hit enter, we can see that on this line, cost has been changed to 20, but our calculation of 2 times cost has not been updated yet until we click enter on that. Similarly, we can define functions. To do this, we use the same notations, so I could define a function f, and then I use the notation x maps to. So to write this, I can write dash and then the greater than sign, and it will automatically update to the arrow. And then I can write the output, so something like x squared. Click enter, and we see we have a function that takes x and outputs x squared. To call this function, we can use the notation f and then brackets 2 to call it at a singular value. Or I could even write something like f at x to get the general output. In a Maple document, we can use a combination of text and non-executable math, which is math that we don't want Maple to evaluate since it's not a calculation. You can imagine that this would be incredibly useful if we have a longer document with sections that include math that doesn't need calculation. Ideally, we would like to be able to use the Execute Worksheet button after making a variety of changes, but if this math is in the regular math mode, then it will evaluate and mess up the format of the document. So it's incredibly useful to be able to use a combination of the 3 different modes. To switch between the 3 modes, we can use the drop-down menu here at the top, or F5 to cycle between them. We can start by entering in some text, so switch to text mode, and then we could write something like, we can express the solution as, then we could switch to non-executable math mode, write whatever we want our solution to be. Maybe it's x squared plus 1, right? Then we could switch back to text and continue our sentence. So dot dot dot. So this way we get a combination of non-executable math and text in the same line. We can also have calculations using the context panel mixed in with text. So, for example, we can say something like, we know that, then we could switch to executable math and write something like x squared minus 2x plus 1, head over to the context panel and choose factor. It will do the evaluation. Then we can go back and replace this factor equals sign, so delete this. Now we can switch to text mode, and we can say something like can be written as, and then this way we have executable math within our text. We can also make changes, so we can replace the plus 1 by minus 15, then highlight the entire section and use the execute selection button in the ribbon, and it will update our sentence according to our new changes. As an additional tip, if you're not sure which mode you're in, you can tell because text mode doesn't have a box, just the cursor. Non-executable math has a gray box around the section, and executable math has a blue box. We can now transition into talking about plotting in Maple. For example, we can type the expression we'd like to plot, maybe negative x squared plus 15. Head over to the context menu and choose plots, 2D plot to get a nice plot of this expression. We can manipulate this plot in several ways using the plot manipulator tools found in the plot ribbon up here and also in the context panel. For example, we can pan around the plot by selecting this option right here and using the left mouse button to click and drag myself around. Additionally, we can zoom in and out by using the plus and minus magnifying glasses and selecting the region to zoom in on. Also, we can use the point probe to find the coordinates of points on the curve. To do this, select this first button right here, and then the third option here, and drag around the curve, and you'll get points popping up that are located on the curve. For example, we can consider the second expression, maybe sine squared x. Again, same thing, head over to the context menu, choose Plots 2D Plot. And something you may want to do frequently is combine plots. This is very easy to do in Maple. All you have to do is type the expression of the plot you want to add, so maybe sine of x over 2. Then highlight this expression and click Control and drag it onto the plot you'd like to add it to, and you'll get a plot of both expressions. Now, especially with combining plots, something you may want to do is annotate these plots. You can add additional information, such as drawing tools, lines, arrows, text, 2D math, and shapes. To do this, all you have to do is select the Draw tab. Now we want to add a label, so I'll select the text button here off to the left, and we can drag to create a text cell and add an annotation, maybe sine of x over 2, just to illustrate that that's what this is. And then now click off and you have an annotated plot. We can also do 3D plots in Maple in a similar way. All we have to do, type in the expression we want, so maybe sine of x times y. Then head over to the context menu and choose plots, but this time click 3D plot and then the order which you would like your variables. Now you can see we got a nice 3D plot of this expression. To rotate the plot, all you have to do is click down on the plot and then move your mouse to wherever you like to rotate. Additionally, we can use other plot manipulator tools in the plot ribbon up here, such as pan, we can pan around, or the zoom magnifying glasses described earlier. Additionally, you can modify the look of your plot in a variety of different ways. Plot options can be changed using the context panel, and the available options will depend on the type of plot. In this case, we can make sure our plot's selected, head over to the context menu, and change things such as the transparency or the color. Additionally, a cool feature available in Maple is the plot builder. Plots and animations can easily be created and customized in Maple using the plot builder. You can choose the type of plot you want and set options all at the same time. The plot is updated instantly so you can see the results of your choices. For example, we can do this on the expression x squared plus y squared. Head over to the context menu and choose plot builder. Then we can select the result and we'll open up the plot builder where the context menu was. Now, the first thing we can do is change the type of plot we have. Right now we have a 3D plot, and we could select maybe 2D contour plot. Then what we can do is make sure we're on basic options and change things such as the thickness of the plot, so we can make the lines thicker. We could also change the color around to something like leaf green. Now what we can do is we can customize this plot further by going to the axes and text option, and then entering a title for our plot. So I can say this is my plot. So type in your title and then hit enter, and you can see it's updating everything immediately. As an additional tip, you can use the plot builder to create and customize your plot, then use the show command option here to see the exact Maple command that would be used to generate this plot. As we just saw, we don't necessarily need to use the context panel to plot things in Maple. We can use commands. So consider the following application of the plot command with arguments sine of x and x. So whenever I hit enter, we'll see it'll generate a nice plot here of sine of x. Now, it's important to note that just because this plot was generated with a command doesn't mean that we can't use the context panel and the plot ribbon up here to modify this plot. Now, something to note is that plot commands can take many different customization options. For example, consider the following application of plot 3D. Now I'll copy and paste it to save myself the time of typing all this out, but all I need to do is add in the expression that I want to plot here, so I'll choose x squared plus y squared. Then what these different customization options are doing is we're assigning the range of -10 to 10 to both the x and y axis, as well as the shading style Zoo, which is one of my personal favorites. Additionally, we're choosing the style of surface, and we're giving the plot a title of My Plot. Now, if I hit enter, we can see that a plot with all these customization options has been generated. Now, if you want to do plots that aren't just a regular 2D or 3D graph, you can head over to the Help tab here, search Plotting Guide as I did in the Maple Help search, click enter, and click on the first result. This result has additional information on how to use different plotting commands. In addition to the plot builder, Maple includes many other interactive tools for performing simple and complex tasks, as well as for exploring concepts. We will be going through some examples, but select the Tools menu as I have now, and you'll be able to find additional ones here. So starting with the Exploration Assistant, the Exploration Assistant allows you to instantly create interactive mini applications used to explore the parameters of an expression, even if that expression involves Maple commands. Explorer generates a user interface with interactive sliders, dials, or gauges that can vary the values for the parameters and show the result. So, for example, we can type in the following expression: plot 3D, then I can do cos of a times x plus b times sine of y. Now, don't click enter yet. Go over to the context panel and click explore. It will open up this menu here, and this is where you can do a bunch of stuff. So, for starters, x and y are supposed to be variables, so we'll keep those, or we'll skip those for the sliders. Now there's a bunch of other different options you have here, but for now, I'll just click explore. And we can see that it'll open up a nice interactive explore page here with sliders for both A and B. Now moving these around, we can see that the plot it provides will update instantaneously for us. So this provides a useful way to kind of experiment with problems and fill any gaps that you may have in your knowledge. Now, it's important to note that the explore functionality is also available through the explore command. So it's just explore, sorry, that should be a capital, explore, command like this. This will provide much more functionality and customization options. Another very interesting tool in Maple are tutors. Maple provides many tutors that can be found in the Education tab, which are useful for teaching and exploring mathematical concepts in calculus, pre-calculus, linear algebra, statistics, and more. For an example of one, we can visit Calculus, Single Variable, and choose Integration Methods. It'll open up the tool in a new window, and we can see that we can enter in any function we like. It defaulted to sine squared of x, which is okay with me, and then we can follow through the example by applying the correct rule at each step. So we have a variety of different options here, and we can choose the one that we think works best. If we get stuck, we can click Get Hint. So it says try rewriting sine squared of x, and we could choose the option that we think works best. If you want to reveal the next step, you can click Next Step. And if you want to see all the steps until the end, you can click All Steps. So this is a very useful tool for being able to work through practice problems, or just to be able to use the interactive display to test your understanding. Another very cool tool that's available in Maple are math apps. These provide interactive explorations of various mathematical and scientific concepts. Math apps are available for many different fields, including algebra, functions, calculus, engineering, and many more. To find them, all you have to do is navigate to the Education tab, which I'm already in, and then click Math Apps. It will open it up here in a new window. So let me bring this over. Sorry, it's just being slow right now. Oops. Let me open it back up. Bring this over. And you'll see there's a variety of different options here, as I mentioned. For instance, we can click on Algebra and Geometry. It'll load here. And then we can click on one of the options, such as conic sections. So if we click on this, it'll open up the math app in our Maple window. So just give it a moment to load. And then we can explore here, moving the sliders around and experiment with this interactive document. So you can see there's a bunch of different options here for things we can change. And these sorts of applications are very useful to be able to conceptualize the concepts that you might be learning in class or are just generally curious about. For more task-specific help, select the Education tab, which I'm already in, and choose the Browse icon. It'll open up this window here. And then you can use this to search through a large collection of task templates for solving problems from calculus, algebra, geometry, differential equations, statistics, and more. Even if you choose not to use the templates themselves, the task templates are still a good resource for learning how to use Maple to solve various problems. While many operations in Maple can be done through the use of the context panel and other interactive tools, Maple also has an extensive set of commands as well as a rich programming language. Maple has over 5,000 commands which you can call directly. Many commands are organized into packages. When calling these commands, you have to tell Maple where to find them. So, to begin, we can define a variable m and store a matrix in it using the palette and the matrix section here. We can insert a matrix and then use tab to work through the template. So we can set up the matrix 1, 2, 3, 5. Hit enter, and we see that m has been defined as this matrix. Now, we can use the determinant command from the linear algebra package to find the determinant of this matrix. So to do this, we type the linear algebra package, so linear, and then now we can use command completion. And in square brackets, we put the function we want to use from the linear algebra package. So that is determinant. Make sure I spelled that right. And then now we feed it m as input, and we'll see it gives -1, which is indeed the determinant of this matrix. As a tip, if you do not provide the package name, so I just write determinant m, then you see it's just going to give this as a result. So if you see something like this, it's usually because you need to tell Maple which package the command comes from, or you've mistyped the command name. You can avoid having to type the long form, which is this, each time by loading the desired package using the with command. This command loads the package and returns a list of all the commands in that package. So I can load with linear algebra, use command completion, and make sure to add a colon to the end of this so it suppresses the output. So now I should have access to the determinant command. So with this being said, I can now use the short form and just write determinant, feed m as input, capital M, there we go, capital M, and we see it gives -1 as we'd expect. Now, something that is very useful whenever doing things like this is command completion. You already may have seen me use it a few times already, but we can use it to get many different functions that are available in a package. For example, we can start typing Gauss, click escape, and then we have a variety of different options here. So I can use Gaussian elimination, click tab, feed it m as input, and then get the result. So it's definitely a lot faster to use command completion, as was explained earlier, rather than typing out Gaussian elimination. As an additional tip, many packages can be loaded through tools, which I'm already in, and then load package. Also, you can check out package list to see a complete list of all packages. Many resources are available to help you find your way around Maple, from how do I guides for new users to information for advanced Maple programmers. You can open the help system at any time from the help tab by clicking this button right here on the far left. It'll open up this tab here. And from here, you can browse the entire help system through the table of contents or search what you need directly. If you know the name of the command you're interested in, then you can bring up its help page by using the question mark command. So what this means is, let's say you're interested in the command is prime. You can type question mark is prime, hit enter, and you can see it'll automatically pull up the is prime help page. As an additional tip, if you just type is prime, let's say it's in your program somewhere, and you want to pull up the help page for this, you can put your cursor on is prime and click F2, and it will also open up its help page immediately. Another great resource to make note of is the Maple portal. To open it up, you can type question mark Maple portal, hit enter, and it will open up the Maple portal in a new window. It brings together a collection of useful resources for learning about Maple, including getting started resources, how do I, mini tutorials, training videos, user and programming manuals, examples and applications, additional resources for students and educators, and how to get additional help.